Now that we've got our recording software that's working, now I wanted to put something up here about ionic compounds. They're made up of these two pieces, cations and anions. You can see some of the characteristics. The cations are the positive ions. They lose their electrons. And those are the metals, the blue ones on the periodic table. Anions are negative ions. They gain electrons to get their stable 8. And they are non-metals, mostly the yellow ones. The green ones, the metalloids, they can go both ways. Often they behave as metals, so they become cations, positive ions, but they can also form anions. So when we're making ionic compounds, our goal is to balance the charges. We want our overall charge to equal 0. That is the goal, the overall charge must equal 0 so that we have an equal number of positives and negatives. So here we have silver Ag working with nitrogen to form a compound. You see silver is a +1, nitrogen is a -3. Together, that would only give you a -2. If I add them together, it just gives me -2, which would not be a stable compound. So how about if we add another Ag? Let's put another Ag as a 1+. Well, then 1+ and 1+ would be 2+. Take away that -3, we'd be down to -1, but still not at 0. So therefore, I have to have a third silver, Ag1+, so that this plus this plus this all will give me 0. So my formula for this compound would then be Ag3N. Similarly, if I want to do that with zinc and phosphorus, zinc is a 2+, phosphorus is a 3-. If I simply add these together, then I'm at -1, not my 0. Remember, 0 is the goal. So let's add another zinc as a 2+. So then my 4+ and my 3- will give me a +1. I don't want that. I want 0. So okay, let's put another one of these P's in there, P3-. Well, if I do that with the 2 zincs, now I'm at 2-. So that didn't help. I need to add a third zinc so that all of these guys together give me 6+. And all of these guys together give me 6-, which gives my total to be 0. So therefore, my formula for this is Zn3P2. And these bottom numbers are telling me the number of atoms of each of those elements. I hope that's helpful for you as you're looking at these ionic compounds. We'll do more with what do we do when elements have more than one of these charges? How do we make those? We use our Roman numerals. And what do we do with polyatomic ions, things that are not just one simple element like zinc that make up an ion? We'll talk about those next.